Hello everybody, welcome to lecture 2. So I think all of you have a paper and a pen with you because this is very important. You don't want to listen this lecture like a movie. So I think all of you should keep a pen and a paper with you when you listen to this lecture. So at the end of this lecture, you should be able to do homework number 8 thoroughly. So the first lecture together with this lecture, you should be able to do homework number 8. So follow this lecture very carefully. So we will do definite integrals. Definite integrals evaluation. We are basically doing evaluation of definite integral. That is how to find out the value of a definite integral. So before the spring break, we had defined definite integral. If you remember that what definite integral represents, we use this symbol, right? Integral from a to b fx dx. And we define this is the definite integral of the function fx from a to b. And we also saw before the spring break, what does this symbol represent? This represents an area. So if my function fx is always positive, that is if fx is always greater than 0, then so xo, x prime, yo, y prime, if my function is always positive and if it is defined in the domain from a to b, that is it is defined in this interval, then if I integrate from a to b fx dx, what do I get? I actually get this area. I get this area. So I get, so this is this. So equal to, so what is this area? It is the area bounded by the curve y equals to fx. So how can we express this area? It is the area bounded by the curve y equals to fx. X equals to a, x equals to b. These are the abscissa. The abscissa or you can call it x equals to a, x equals to b, and the x-axis. So this integral from a to b fx dx, it is the area bounded by the curve, these lines x equals to a, x equals to b, and the x-axis. So this area is given by integral from a to b fx dx, and that is the definite integral of the function fx from a to b. And before the spring break, when we introduced Riemann sum, we saw that this area can be actually broken down into smaller rectangles. If you take a partition, say this is x0, x1, x2, x3, and if you divide it into n parts, if you construct rectangle, then if you take a sample point in each of these subintervals, so if you take x1 star in the first subinterval, you take x2 star in the second subinterval, you take x3 star in the second subinterval, then if you form this sum, you form summation I equals to 1 to n f of xi star times delta xi, right? So you multiply the value at this point with the width delta xi, that is this length. So if you multiply this, you basically get the area of this rectangle. In the same way, you get the area of this rectangle. If you multiply x2 star with delta xi, you get the area of this rectangle. Right? Then so in this way, if you take the sum, you will get the areas of rectangles, and if you take the limit of this one, and this sum is often called the Riemann sum. If you expand it, will be f of x1 star times delta x1 plus f of x2 star times delta x2 plus dot dot so on f of xn star times delta xn. This is the Riemann sum, and if you take the limit of this Riemann sum, lim as n tends to infinity, right? That is, you take the limit as the number of pieces becomes small and n tends to infinity. If you take the limit of this, we studied before spring break that this limit actually gives you this integral or this area. So this integral from a to b of x dx is actually, or the definite integral is actually the limit of the Riemann sum. This is the Riemann sum. And then if you take the limit of the Riemann sum, you get the definite integral. So this is the definition of a definite integral, and this is what it represents. It represents the area. Now the question is, if we want to find out the value of this definite integral from definition, like what we did in case of derivative using definition. So this is the definition of an integral, that it is the limit of this Riemann sum. It's very, but if you see that finding this limit is very tough. You have to first find out the Riemann sum, then compute out its limit, and Riemann sum is itself sometimes very problematic. If you take n large enough, so say if n is 100, so you need to divide into 100 pieces, takes one small. So we have to find out an alternative way of finding this definite integral. So that is what we want to study. So we want to evaluate definite integral without using the techniques that we have studied before spring break. So we want to find out the value of integral from a to b of x dx using some formulas, very easy formulas, just like we have formulas for derivative, just like we have formulas for indefinite integrals that we have studied. The same way we have some formulas for definite integrals also. That is what is the topic of my lecture today. So there is a famous theorem called the evaluation theorem, which helps us to find out the value of definite integral. So let's study now the evaluation theorem. So what is evaluation theorem? Evaluation theorem. So what evaluation theorem is basically a theorem to compute definite integral. So what does this definite integral? So it actually connects definite integral with indefinite integral. We have already studied indefinite integral in my first lecture. We saw that indefinite integral is just the opposite of differentiation. We had some formulas and we did some problems. Now we will see that this definite integral, it can be connected with the indefinite integral that we have studied in the lecture video 1. Okay, so what does this evaluation theorem says? The evaluation theorem says, if a function fx is continuous in a closed interval AB, you have an interval AB and the function is continuous, and Suppose we are able to find out its antiderivative, and say if capital Fx equal to integral of fx dx is its antiderivative, so suppose I know that a function is defined in this interval a to b. So suppose I have a function fx which is defined in the interval ab, right? So let me draw the figure for you so that it becomes easier for you to understand. So I have a function which is defined in the interval ab, right? And somehow using the techniques that we had discussed in the video 1, we are able to find out its indefinite integral or its antiderivative. So antiderivative means indefinite integral. Then evaluation theorem says that if we somehow know its antiderivative or its indefinite integral, this area or the definite integral is very easy. Then integral from a to b fx dx or this area is simply equal to, you find out the value of the antiderivative or the definite integral at b, right? Then you subtract it from the value of this at a, right? So thus it says us that finding definite integral is very easy. To find out definite integral, we just ignore these limits and find out the corresponding indefinite integral using the techniques discussed in video 1. Whatever result you get, it will be a function. In that function, put the top value, you put the bottom value and find their difference. This is exactly what evaluation theorem says. So evaluation theorem says to find out integral from a to b fx dx, first ignore these two limits, then you have an indefinite integral. Its value can be computed out using the techniques discussed in video 1. Then you will get a result which will be a function of x. In that function, put the top value, put the bottom value and find their difference. Whatever difference you will get will be the value of this definite integral, and hence that will represent the area bounded by this function and the x-axis. Okay, so let's take an example to understand this. An example. Suppose we want to find out the value of, say, integral from minus 2 to 1 x cube dx. This is my problem. Find this. So how to do this? So evaluation theorem says to find out this, just ignore the limits. You forget minus 2 and 2 and consider this function. You ignore the limits and just consider this function. You name it as, say, capital Fx. Whatever the result of this we get. And then use the tools that we used in video lecture 1. So what was the tool? We studied that integral of xn dx, this is simply x n plus 1 by n plus 1. That was the thing we have studied in lecture 1. So it is 3. So it will be x 3 plus 1 by 3 plus 1 plus, don't forget vet c, so you get x 4 by 4. So first thing will be to do this. Then evaluation theorem says, okay, then integral from minus 2 to 1 x cube dx is simply the value of this function at 1 that is f1 minus the value of this function at minus 2. So that is, if you put 1 here, you get 1 to the power 4 plus 4 plus c. If you put minus 2 here, you get minus 2 to the power 4 by 4 plus c. So if you simplify this, you get 1/4 plus c minus, if you simplify 2 to the power 4 is 16 by 4 plus c. So you get 1/4 plus c minus 4 minus c. C cancels out. You get 4 times, you get 1 by 4 minus 4, which is 1 minus 16 by 4, that is minus 15 by 4. Thus, this is how we find out definite integrals. So first, forget the limits. Just treat it as an indefinite integral. You find out the value. Then whatever value you get, for example, I got x to the power 4 by 4. In that value, plug in the top value. The top value was 1. Then plug in the bottom value and find their difference. Here the difference was minus 15 by 4. So that's our result, the answer. So it's very, very easy. So we don't have to do Riemann sum, nothing. Just simple technique gives us the value of, nor we need to take limits. Simple. So finding definite integral using this tool is so easy. Now we are going to do the problems. There are 12 problems in the definite integral. Let's do them one by one. So the first problem is evaluate integral from 1 to 2 1 by x square minus 4 by x cubed dx. So in accordance with the evaluation theorem, so first we will forget the limits, just do this 1 by x square minus 4 by x cubed dx, right? So first forget the limits and just try to do this. So you get 1 by x squared dx minus 4 by x cubed dx. Then the first one, 1 by x square is x to the power minus 2. Constants can be taken out. You are left with 1 by x cubed dx, right? Now you get x to the power minus 2 dx minus 4 x to the power minus 3 dx. Now then, using the formula integral x n dx equal to x n plus 1 by n plus 1, you get this is x minus 2 plus 1 by minus 2 plus 1 minus 4 x minus 3 plus 1 by minus 3 plus 1 plus c. So you get minus 1 over x plus 2 over x square plus c. This is, if you simplify this, this is what you get. Now, evaluation theorem says, after you get this answer, then what you need to do is plug in this answer, the top value and the bottom value, and find their difference. Therefore, integral from 1 to 2, 1 by x square minus 4 by x cubed dx is given by, just you put first the top value, that is 2 here, you get minus 1 by 2 plus 2 by 2 square plus c. Then you put the bottom value, you get minus 1 by 1 plus 2 by 1 square plus c. So this is minus half plus c minus 1 plus 2 plus c. So minus half plus half cancels out. Here ultimately you get c plus 1 minus 2 minus c. C cancels out, you get minus 1 at the end. So you get minus 1 as your answer. So this is how you need to do all the problems. Now let's take the second problem. Integral from 0 to pi by 4 sec square x dx. To find out this, first of all, as usual, we'll ignore the limits and just consider this. Integral sec square x dx is simply tan x. So then by evaluation theorem, plus c would put c whenever you are doing indefinite integral. Then by evaluation theorem, this one will simply be just put pi by 4 here, tan of pi by 4 plus c, then put 0 here, tan of 0 plus c. So you get 1 plus c minus 0 plus c. You just get so 1 as your answer. C get cancelled. You will see that always c's will get cancelled. So in the when you find out definite integral, in the final answer will be no c, because c's will always get cancelled. Okay, so now let's do the third problem. Integral from 0 to 1 3 plus x square root of x dx. So this is x times square root of x. Now not it's xth power, it's x times square root of x dx. So how to do it? Very simple. Forget the limits, just find out 3 plus x square root of x dx. So what you do, you just first break it, you get integral 3 dx plus integral x square root of x dx. So this is 3, you take out, you get dx. You can write down x times square root of x as x times x power half dx. So this is 3 integral of dx is just x, and you can add the powers. Here the power you have 1 plus half, so it will be x to the power 1 plus half dx, 3x plus x to the power 3 over 2 dx, right? So this is as a formula, x to the power 3 over 2 plus 1 by 3 over 2 plus 1 plus c. Don't forget to put c. So you get the answer as 3x plus x to the power 5 over 2 by 5 over 2 plus c. So ultimately you get 3x plus 2 over 5 x to the power 5 over 2 plus c. Now once you have found out this value, just plug in the top value. Integral from 0 to 1 3 plus x square root of x dx. Put the top value, you get 3 times 1 plus 2 by 5 times 1 to the power 5 over 2 plus c, minus, if you put 0, 3 times 0 plus 2 over 5, 0 to the power 5 over 2 plus c. Now if you simplify this, you get 3 plus 2 over 5, c and c will get cancelled, 5 3s are 15, you get 17 by 5 as your answer. Okay, so now let's take the next problem. Problem number 4. So the problem was this: we have to find out integral from 0 to pi 4 sin x minus 3 cosine x dx. So what's the problem? So first forget the limits, just consider this: 4 sin x minus 3 cosine x dx. You can break it as integral 4 sin x dx minus integral 3 sin x dx. So 4 can be taken out, 4 integral sin x dx minus 3 integral sin x dx. Now this is cosine x. Now you see, once you do this, integral of sin x is minus cosine x and integral of cosine x is just sin x plus constant of integration. So if you simplify this, you get minus 4 cosine x minus 3 sin x plus c. Now find out this, you put pi here, you put 0 here, and find out the difference. So therefore, integral from 0 to pi 4 sin x minus 3 cosine x dx is, first you put pi is here, so you get minus 4 cosine pi minus 3 sin pi plus c, and you put minus, you put 0. If you put 0, you get minus 4 cosine 0 minus 3 sin 0 plus c. You get minus 4 times minus 1, 3 times 0 plus c, minus 4 cosine 0 is 1, 3 times 0 plus c. You simplify, you get 4 plus c plus 4 minus c, c cancels, you get 8 as your answer. It may be not visible, it's 8. Let's take the next problem now. integral from 1 to 4 square root of x times 1 plus x dx. Same thing, first forget the limits, just find out square root of x times 1 plus x dx, right? This is equal to, so you multiply square root of x times 1 gives you square root of x plus square root of x times x, so it is square root of x times x dx. This is equal to square root of x plus x to the power half plus 1 dx. This is x to the power half plus x to the power 3 over 2 dx. So this is, if you split it, you get x to the power half dx plus x to the power 3 over 2 dx, x to the power half plus 1 by half plus 1 plus x to the power 3 over 2 plus 1 by 3 over 2 plus 1 plus c. So you get x to the power 3 over 2 by 3 over 2, x to the power 5 over 2 by 5 over 2 plus c. You get 2 over 3 x to the power 3 over 2 plus 2 over 5 x to the power 5 over 2 plus c. That was the value you get. Now once you find out this, then integral from 1 to 4 square root of x times 1 plus x dx is, first put in this expression 4, so you get 2 over 5, 4 to the power 3 over 2 plus 2 over 5, 4 to the power 5 over 2 plus c minus 2 over this is actually 3, right? This is 3, so it should be 3 plus minus 2 over 3, 1 to the power 3 over 2 plus 2 over 5, 1 to the power 5 over 2 plus c. So this is 2 over 3 times 2 cubed plus 2 over 5 times 2 to the power 5 minus 2 over 3 minus 2 over 5 minus the cc gets cancelled, so it is 16 by 3 plus 64 by 5 minus 2 over 3 minus 2 over 5. So ultimately 16 minus 2 is 14 by 3 plus 64 minus 2 is 62 by 5, right? And now if you use calculator and find out the value, you get 14 division 3 plus 62 division 5. You get 17.06 as your answer. Now let's take the next problem. Now let's take the next problem, which is problem number 6, which is integral from 1 to 9 3x minus 2 by square root of x dx. So first we will consider this 3x minus 2 by square root of x dx. So as I told you in my first video, whenever you have two term in the more than one term in the numerator and one term in the denominator, you have to split this. So you get integral 3x by square root of x dx minus 2 by square root of x dx. So now you can take the constants out. You get x by square root of x dx minus 2 integral dx by square root of x. Now you see you have 1 power 1 and power half. So it is x 1 minus half dx, and 1 by square root of x can be written as x power minus half dx. So you get 3 x power half dx minus 2 x power minus half dx. Now once we have done up to this, it's very easy. Just using the formula, x n dx is x n plus 1 by n plus 1. So using that, it will be 3 x power half plus 1 by half plus 1 minus 2 x minus half plus 1 by minus half plus 1 plus c. So this will be 3 x to the power 3 by 2 by 3 by 2 minus 2 x to the power half by half plus c. So this ultimately gives you 3 times 2 over 3 times x to the power 3 over 2, 2 times 2 times x to the power half plus c. So ultimately you get 2 x to the power 3 over 2 minus 4 x to the power half plus c. In this expression, put the top and the bottom and find the difference. So therefore, integral from 1 to 9 3x minus 2 by square root of x dx. This is equal to, first put 9, 2 times 9 to the power 3 over 2 minus 4 times 9 to the power half plus c minus, if you put 1 in place of x, you get 2 times 1 to the power 3 over 2 minus 1 to the power half plus c. So it is get, so what you get, so here you get 2 times 3 cubed minus 4 times 3 plus c minus 2 minus 4 plus c. Now finally you just simplify this using calculator. 27 minus 12 you get 44 as your answer. Okay, so now let's do the next problem, which is very important. So how to deal with such functions where you have these bars or these absolute values? So step 1, equate whatever is under the inside the bar. So here you see what is inside the bar. You have x minus 3 inside the bar. So equate that to 0. So x minus 3 equated to 0 gives you x equals to 3. Put the value of x you get on solving it on the number line. Put the left endpoint, put the right endpoint. Then you see that you have two parts here. Take a number here, take a number here. So if you take a number between 3 and 5, what do you get? You get 4. Take a number here, you get say 2.5. Put these two numbers in this function. The function here is x minus 3. Put these two numbers, put 2.5 and 4 in this function. So if you put 4 in this function, you get 4 minus 3, which is 1, so I get a plus sign. If I put 2.5, I get 2.5 minus 3, which is minus 0.5, which is a negative sign. Now, once we have determined the sign, we just split this integral. So here we have from 2 to 5. So what we do, we write this as follows. First, from 2 to 3. From 2 to 3, absolute value of x minus 3 dx. And then from 3 to 5, whatever absolute value of x minus 3 dx. Then, since you have a minus sign here from 2 to 3, you will now open the bars. And open the bars, and since you have a minus sign, you will put a minus in front. So it will be 2 to 3 minus of x minus 3 dx. Now here, since it was positive, so when you open the bars, you will have plus x minus 3 dx, which is same as x minus 3 dx. So clearly, if you have an absolute value, the first thing would be to get rid of these bars, because unless we have bars in our integral, we will not be able to find out. This is the technique how to get rid of bars. Whatever is inside the bars, equate that to 0, solve for x. Here I get x equals to 3. Put this on the number line, put the two endpoints, 2 and 5 also. You take a number here, you take a number here. If you put 4 in this function x minus 3, I get a plus sign. I get 4 minus 3 equals to 1, so I get a plus sign. If you put the number 2.5 in this function, you get a negative sign. Once you have determined the sign, you break the integral from 2 to 5, first from 2 to 3 and then from 3 to 5. Here from 2 to 3, since I have a negative sign, when I will open the bars, I just put minus in front. And when from 3 to 5, since I have a plus sign, when I will open, I put a plus in front. That is, putting plus and not putting plus is the same thing. Now once we have done this, now we are good. So first we will just do, since it is minus x minus 3, it is minus x plus 3 dx plus 3 to 5 x minus 3 dx. Now to evaluate, now we evaluate these two. So as we have seen, first of all, now let's try to simplify this. So to find out the value of integral from 2 to 3 minus x plus 3 dx, we have to first of all find out the indefinite integral and then the definite integral. So let's do it in a shortcut way. So the first one, so since we have to find out the indefinite integral of this, just forget these two limits and just try to do it as follows. So you just break it from 2 to 3 minus x dx plus from integral from 2 to 3 dx plus you have integral from 3 to 5 x dx minus integral from 3 to 5 3 dx. Now once we do this, you see that take the first term, you are finding integral from 2 to 3 minus x dx. So we know that how to find out definite integral. First find out the corresponding indefinite integral. What is the indefinite integral of minus x? It is minus x squared by 2. Why is it so? Because integral minus x dx, you can take minus out, you get x dx, then using that formula it is x 1 plus 1 by 1 plus 1, so it is minus x squared by 2, right? So it is minus x squared by 2, put the two limits 2 and 3. Then you see in the second part you can take this 3 out and then you evaluate the integral. You will see that the value of this integral is 3x. So you put 3x, then put 2 and 3. In the third one, the integral of x is x squared by 2. So you put x squared by 2, put 3 over 5. The last one, you see that you have 3 and its integral is just 3x. Indefinite integral is 3x. You put 3 over 5. Then you put the top value, the bottom value and find the difference. So if you put 3, you get minus 3 squared by 2 plus, because minus minus of minus 2 squared by 2 plus, you get 3 times 3 minus 3 times 2 plus 5 squared by 2 minus 3 squared by 2 minus 3 times 5 minus 3 times 3. Okay, so this is what you get. Now finally, if you simplify this, you will get let me write down the answer here. You will get minus 9 over 2 minus, so here minus 2 squared by 2 you have, so you put minus 4, so minus 4 over 2, so this is minus 2 plus 9 minus 6 plus 25 by 2 minus 9 by 2 you get minus 15 minus 9. So this is equal to minus 9 over 2 plus 2 plus 3 plus 25 over 2 minus 9 over 2 minus 6. So ultimately you will get minus 9 plus 5 minus 6 plus 25 over 2, so you get minus 4 minus 6 plus 25 over 2, you get minus 10 plus, it's not visible to all of you, let me switch it here, so now it might be visible, so it's minus 10 plus 25 over 2, so it's minus 20 plus 25 over 2, you get 5 over 2 as your answer. So just let me say again the various steps of doing this problem. So the first step, so this was my original problem. So integral from 2 to 3 mod of x minus 3 dx. First equate whatever was inside x minus 3 to 0. You get x equals to 3. Put this 3 on the number line, put the two endpoints 2 and 5 on the number line, right? Then you take a number here, take a number here, you get 4, you get 2.5, put them on the function, determine the sign. Once you determine the sign, you break it from 2 to 3, from 3 to 5. So here from 2 to 3 I have a negative sign, so when I open the bars I will have a minus sign. From 3 to 5 I have a plus sign, so when I open the bars I have a plus sign. Once you do this, then you simplify this, right? So you get minus x plus 3 dx plus integral from 3 to 5 x. Once you reach this step, the rest part is very simple. It's just how we did the earlier problems. Evaluation of definite integrals. So first find out the corresponding indefinite integral and then put 3 and 2 and find the difference. Here also you find out first of all corresponding indefinite integral, then put 5 and 3 and find their difference. At the end you should get 5 over 2 as your answer. This is how it is. So after this part it is just our ordinary integrals. So first find out the corresponding indefinite integral, the corresponding indefinite integral here also. Here put 5 and 3 and find their difference. Here put 3 and 2 and find their difference. Now let's take the next problem. Problem number 8. So I will also send you the solutions to the problem. So if you somehow are not able to see or have some problems, you can just also have the ready-made solutions. But right now just try to understand. So this is 8. Okay, so question number 8 is integral from integral from 0 to pi by 3 sine x plus sine x tan square x whole divided by sec square x. So the same technique, first you will forget the limits, just find out the corresponding indefinite integral. This problem we had already done before. So sin x plus sin x tan square x divided by sec square x dx. So you will factor sin x out, right? So if you factor sin x out, you get 1 plus tan square x divided by sec square x dx. 1 plus tan square x is sec square x divided by sec square x dx. Sec square x cancels out, you get just integral sin x dx, yes, minus cosine x plus c. Now once you do this, you just put here in this function the top value, bottom value and find the difference. Therefore integral from 0 to pi by 3 sin x plus sin x tan square x by sec square x dx. It will be just put pi by 3 here, so you get minus cos pi over 3 plus c, then put 0 here, you get minus cosine 0 plus c. So you get cos of minus pi over 3 is cos 60 degree, which is half, plus c minus cos of 0. If you don't know these values, you can definitely use calculators. So it will be minus 1 plus c, cosine of 0 is 1. Then you just simplify this, you get minus half plus c plus 1 minus c. So ultimately you get half as your answer. So this is how you do this problem. Now let's do the next problem. You have problem number 9, which is integral from 0 to 1 3 plus x square root of x dx. Right? So now first forget the limits, just consider this integral. So you have integral 3 plus x square root of x dx is equal to integral 3 dx plus integral x square root of x dx. So this is 3, you can take out and write this as x times x to the power half dx. You get 3x plus integral x to the power 3 over 2 dx. This is 3x plus x to the power 3 over 2 plus 1 by 3 over 2 plus 1 plus c. So this is 3x by x to the power 5 over 2 by 5 over 2 plus c. So this is 3x plus 2 over 5 x to the power 5 over 2 plus c, and then put the top value and the bottom value and find their difference. So if you, this is your answer. So therefore integral from 0 to 1 3 plus x square root of x dx, just put the top value, you get 3 times 1 plus 2 by 5 1 to the power 5 by 2 plus c, minus put the bottom value 3 times 0 plus 2 by 5 0 to the power 5 by 2 plus c. You get ultimately 3 plus 2 or 5 as your answer. You get 17 by 5. So now let's take the next problem, which is problem number 10. Is integral from 1 to 2, 1 plus 2x whole square dx. So first of all, you will forget the two limits and just consider this value. So integral 1 plus 2x whole square dx. To evaluate this, you have to use this formula: a plus b whole square equal to a square plus twice ab plus b square. Using that, you can break it down and write this as 1 square plus 2 times 1 times 2x plus 2x whole square dx. So this is equal to 1 plus 4x plus 4x square dx. So this is equal to integral dx plus integral 4x dx plus integral 4x square dx. So this is, the first one is x, the second one is 4 times x square by 2, the third one is x cubed by 3. So you get x plus 2x square plus 4 by 3 x cubed, plus of course a c at the end. Then here you put the top value and the bottom value and find their difference. So therefore, integral from 1 to 2, 1 plus 2x whole square dx is, put the top value, you get 2 plus 2 times 2 square plus 4 by 3 times 2 cubed plus c. Then you put the bottom value, you get 1. You put the bottom value, you get 1 plus 2 times 1 square plus 4 by 3 1 cubed plus c. Then just use a calculator. So if you use a calculator, you get 49 by 3 as your answer. Which is 16.33 approx. Now problem number 11. So problem number 11 is integral from 0 to 2 to mod of 2x minus 1 dx. Again we have an absolute value problem. So how to do it? We equate whatever is inside the mod, that is 2x minus 1 to 0. So we equate them, 2x minus 1 equals to 0. You get x equals to half. Put this half in the number line. Also put the left end point and the right end point. So the left end point is 0 and the right end point is 2. Now what you do is you take a number in this interval half to 2. So a number in the interval half to 2 is 1. A number between 0 and half is 1/4. right? Now you put 1 in this function, 2x minus 1. If you put 1 in this function, 2x minus 1, you get 2 times 1 minus 1, you add a plus sign, right? If you put 1/4, you get a negative sign. That means when you will open this from 0 to 2, you will break it as integral from 0 to half mod of 2x minus 1 dx, plus we will break it from half to 2 mod of 2x minus 1 dx. Now what happens is, when you take the bars in the first integral, you have a minus sign. So when you take the bars, you will get minus 2x minus 1 dx, and when you take the bar in the second integral, you have a plus sign. So plus 2x minus 1 dx. Finished. And then it's our ordinary integral. So to find out the first integral, so in order to evaluate this nicely, let's write it as I1 plus I2, where I1 is the first integral from 0 to 2 minus 2x minus 1 dx, and I2 is integral from half to 2x minus 1 dx. So to find out I1, the same thing, first forget the limits and just do the corresponding indefinite integral. So minus 2x minus 1 dx is integral minus 2x plus 1 dx. So and its value is minus 2 times x square by 2 plus x, which is minus x square plus x. This is the value. Now here you will put the top and the bottom. So if you put 2 here, and here you will get minus 2 square plus 2. If you put the bottom 0 here, you will get minus 0 square plus 0. This will be your I1. So it will be minus 4 plus 2 minus 2. This is the value of I1. Similarly, to find out I2, we first forget the two limits and just perform whatever was inside. So integral 2x minus 1 dx, this is 2 times x square by 2 minus x. So this is x square minus x. Now in this function, we will first put 2 and half. If you put 2 here, you will get, in this function x square minus x, you get 2 square minus 2 minus, if you put half, you get half square minus half. Don't forget to put a bracket, otherwise we will mess things up. So this is 2 minus 1/4 plus half. This is equal to 2 minus 1/4 plus 1/4. So you get 9/4 as your answer. So I1 is minus 2, I2 is 9/4. So if you add them, so minus 2 plus 9/4, you get minus 8 plus 9/4, you get 1/4 as your answer. Okay, now let's do the last problem. It is problem number 12. So problem number 12 is integral from minus 1 to 2 x minus 2 absolute value of x dx. Now what is the quantity that is under mod or the bars? It is just this x. Here it is very important, you don't have to equate everything to 0. You see that the only thing that is under bars is this x, so you have to just equate this x to 0. So you get x equals to 0, so put this on the number line with the other two, minus 1 and 2. Then you take a number in this interval, minus 1 0 and 0 2. One number here is 1 and one number here is minus half. Put minus half and 1 in the function. The function here is just x. So if you put 1 in this function, it is definitely positive, you get 1 as the answer. If you put minus 1 half here in the function, you get minus half, so it is negative. That means when you will open the brackets, so we will split this integral from minus 1 to 0, x minus 2 absolute value of x dx, plus from 0 to 2 x minus 2 absolute value of x dx. In the first one, when you will open this bar, you will have a negative sign. So if you open these bars, you will put a negative sign. So it's minus 1 to 0, x minus 2 minus x dx, plus from 0 to 2 x minus 2 times x dx. Here it will be just x because I have a plus sign. Now you simplify this, minus 1 to 0, x plus 2x dx. In the second one, you get 0 to 2, x minus 2x dx. If you simplify this, you get minus 1 to 0, 3x dx. The second one, minus x minus just minus x dx. Now, how to find out them? So these are pure definite integrals, no bar, nothing. So our old techniques apply. First, find out the corresponding indefinite integral. The indefinite integral of 3x is 3x squared by 2. Put minus 1 0 because we need to put them. The indefinite integral of minus x is minus x squared by 2. Put the top value, the bottom value, and their difference. So if you put 0 here, you get 3 times 0 squared by 2 minus, if you put minus 1, you get 3 times minus 1 squared by 2. In the second part, if you put 2 here, you get minus 2 squared by 2 minus, if you put 0 here, you get 0. So finally, if you simplify this, you will see that you get minus 3 over 2 minus 2. So it is minus 7 over 2. So this brings us to the end of the problems on evaluation of definite integral. Now we will do average value of a function. Okay. Average value of a function. Okay, so this average value of a function is a topic which plays a very crucial role in applied sciences, particularly in medicine, in economics, in engineering. To explain this situation, let me take a very easy example, which is going on around us. This is coronavirus. Suppose a doctor wants to find out what is the average temperature of a critical coronavirus patient. So what he will do, he will measure the temperature of the patient, suppose in a given period, say 14 days. So it's like for 14 days the doctor measures the temperature of the patient. So let us denote a function f, right, which denotes the temperature of the patient. Right? Now suppose f1 represents the temperature of the patient in day 1. The same way, suppose f2 represents the temperature of the patient at day 2, and in the same way, suppose going on, f14 represents the temperature of the patient on 14th day. So the doctor, what he does, he collects this information and takes it to a scientist or a mathematician for doing an analysis of this. So what the mathematician does or the scientist does is that instead of these 14 values, he'll give you one value which would represent all the temperatures. So instead of taking 14 values of a function, he will give you one value. This is not the average temperature, this is some temperature which would reflect how the normal the obvious or the normal temperature of the patient. So instead of these 14 values, I'll give you one value which would represent all these 14 values. That is called the average value of a function. So instead of considering these 14 values, I will give you one value with the aid of mathematics which would represent all these 14 values. This makes it easier to analyze and for all the other purposes. So this is called the average value of a function. So average value of a function is a number. That number represents all the values of that function. It's one single number. So a function can take many values. Some functions can take infinitely many values, right? For example, if you take fx equals to x cubed, this function takes infinitely many values. But what we will find out one value which will represent all the values represented by this function. This is called the average value of function. You can understand how important this concept plays in applied sciences, in engineering, medicine, in chemistry, and everywhere. So the formula for the average value of a function is very simple. Now write here on the formula: if a function fx, right, is defined in this interval AB, right, then its average value is given by FAVE. This is the formula for average value. This is equal to 1 by b minus a integral from a to b fx dx. This is the formula for average value. If we know the function and if we know the interval in which the function is defined, that is the domain, in other words the domain of that function, then we can just calculate the average value using this formula. FAVE equals to 1 by b minus a, just put b, the value of b, and the value of this definite integral from a to v fx dx. This formula gives you the average value of a function. This formula has to be quoted to memory. So FAVE, or the average value of the function, equal to 1 by b minus a integral from a to b fx dx. Now let's do some problems. So since all the problems, actually I have solved all the problems and I will be sending to you in the form of a PDF file. So and because of the lack of time, I'm not going to go through all just like the earlier sections. I'm not going to do all the problems now. I'm just going to do one problem, one average value problem, and the remaining problems, the solutions I'll send you through PDF and you can match them. but you should work each of the problems. So let's take the first problem. Find the average value of the function fx equals to 4x minus x square in the interval 0, 4. This is my problem. So find the average value of the function fx equals to 4x minus x square in 0, 4. So here this is your function and this is your interval. Solution. So here, so since the domain is 0, 4, so here a is 0 and b is 4. So we can directly use the average value formula. FAVE equals to 1 by b minus a integral from a to b fx dx. So here b is 4, a is 0. So a, just put 0, 4, and fx is 4x minus x squared dx. So let's simplify this. 1 by 4 integral from 0 to 4, 4x minus x squared dx. Right, now you see, now we have to just find out this integral from 0 to 4, 4x minus x squared. So finding definite integral is very easy. We did a lot of problems, so let's do it. So first we need to forget these limits and find out just this definite integral. So integral 4x minus x squared. What is the formula? Formula is integral 4x dx minus integral x squared dx. So 4 can be taken out. You get integral x dx minus x squared dx. So integral of x dx is x squared by 2. Integral of x squared dx is x cubed by 3. So this is 2x squared minus x cubed by 3. This is the value. So you, in this value you put 4 and put 0 and find out the difference. So it will be 1 4 times 2 times 4 squared minus 4 cubed by 3. Then you put 0. 2 times 0 square minus 0 cubed by 3. So you get 1/4. 16 times 2 minus 64 by 3. So you get 4 times 2 minus 16 by 3. So this is 4 times 6 minus 16 by 3. This is 24. So ultimately this is 24 minus 16 by 3. So you get 12 by 3, which is, you get 4 as your answer. So you'll get 4 as your answer. So let's do one more average value problem and then let's call it for the day. So find the average value of fx equals to 1 plus x square in minus 1t. This is minus 1t. Okay, so now the same formula here. Fx is 1 plus x square, here a is minus 1 and b is 2. So the formula for average value holds. So f a b e is given by 1 by b minus a integral from a to b fx dx. So this is, put the value of b here, it is 2. Put the value of a here, it is minus 1. Put the values of a and b here also, it should be minus 1 to 2. Fx is 1 plus x squared dx. So it is 2 plus 1 is 3, minus 1 to 2, 1 plus x squared dx. So first of all, to find out this, we'll forget the limits and find out 1 plus x squared dx, which is integral 1 dx plus integral x squared dx. So this is x plus x cubed by 3. Now once we find out that, put x plus x cubed by 3. Now we have to put the top value and the bottom value. So if you put the top value, you get 2 plus 2 cubed by 3. You put the bottom value, you get minus 1 plus minus 1 whole cubed by 3. So this is 1/3 2 plus 8 by 3 minus 1 minus become plus 1/3 by 3. Simplify this. So you get 1/3 1 plus 9 by 3. So you get 1/3. So you get 7/3 as your answer. So it is very simple. Just you need to remember this formula: 1 by f a b equals to 1 by b minus a integral from a to b fx dx. Once you know this formula, you will be given a function, you will be given an interval. The left hand point will be a, the right hand point will be b, and this is your function. Just put the value of a, b and find out the integral, you will get the answer. The answer you will get is the average value. So what we have studied in the first and the second video will be enough for you to do homework number 8. So now, after watching the first and the second video, this video, you are in a position to do homework number 8. So all of you should work homework number 8. If you have any problems working homework number 8, you can communicate with me and I'll be glad to help you. So, but while watching these videos, as I told you, you should always use a pen and a paper technique. Don't watch them like a movie, you will not understand anything. So go through each of the problems that we did. So I'll give you the, as I told you, that I'll scan these solutions and I'll send you the solutions to all the problems in the notes. You have to work them meticulously, each and every one, so that you understand, and then you do homework number 8. In that way you will get a complete understanding. So for the benefit of me and for the benefit of you, I am going to conduct tests in a different manner, not like the earlier format. It is probably I'll use the multiple choice question format. So what does that mean? In test 3 will be given, say, 15 problems. All of them will be multiple choice. Multiple choice means there will be 4 answers. You have to choose the correct answer. You don't have to show your any working in any of the problems. So you will write, when you will write down the answers, you will put the question number and you will put your the choice out of A, B, C, D, and I'll grade them. So it makes it easier for me to grade, and also it becomes easier for you because you don't have to show your working. So in that way, that is the technique probably I'll using that technique, I'll use the tests regarding the test, but details information about the tests I'll upload in the later videos. So right now you watch, just do these problems, do the homework 8, and that's it, and just wait for my next instruction. You can just copy it if you want, and then we can